Go. Hey guys, so today we're going to be doing proof by contradiction. We're going to be doing the second one in my midterm portfolio, which is question number 9, prove that the square root of 3 is irrational. So to start off proof for this by contradiction, we must state that we will be proving by contradiction. So I said to prove this statement, we will prove by contradiction. Next, we are going to say that we suppose that there exists a rational number r where r is equal to a over b and r squared is equal to 3. Next, we're going to let the greatest common divisor of a and b be 1. Next, I rewrote the equations a little bit to make them more simplified into what we can work with. So I said r squared is equal to 3, and then I replaced the a squared over b squared, because it's equal to r, is equal to 3. A squared is equal to 3b squared. And then next we are going to be dealing with case number 1, which is suppose b is even. If b is even, b squared is even, and thus 3b squared is also even. This then applies that a squared is even and a is also even. But if both a and b are even, then the greatest common divisor of a and b is greater than or equal to 2. This is a contradiction of our original assumption that the greatest common divisor of a and b is 1, which we previously stated up here. So for case number 2, we are going to suppose that b is odd, which then implies that b squared is odd and 3b squared is also odd. This then implies that a squared is odd, thus a is also odd. Since a and b are both odd, we can write it as a is equal to 2m minus 1 and b is equal to 2n minus 1 for some m n in the natural number n by the definition of odd. So here I have worked out these two equations, plugging them in for a squared is equal to 3b squared. So I had 2m minus 1 squared for a squared and 3 times 2n minus 1 squared for 3b squared. I then got 4m squared minus 4m plus 1 is equal to 3 times 4n squared minus 4n plus 1. This then goes to 4m squared equal to 4m plus 1 is equal to 12n squared minus 12n plus 3. Next we get 4m squared is minus 4m equals 12n squared minus 12n plus 2. Next, we're going to divide both sides by 2 and get 2m squared minus 2m is equal to 6n squared minus 6n plus 1. Next, we're going to factor out the 2's. 2 times m squared minus m is equal to 2 times 3n squared minus 3m plus 1. So then we get 2 times m squared minus m, the left side of the equation, is even, while 2 times 3n squared minus 3n plus 1, the right side of the equation, is odd. Thus is a contradiction. Therefore, there exists no rational number r such that r squared is equal to 3. Therefore, the square root of 3 is irrational. End proof.